Yes. Okay, good. So first of all, thanks for the invitation to give the talk here today. I will talk about managing research data with OpenBIS. And my name is Caterina Barillari, and I work in the scientific IT services of ETH Zurich. So this is a section of the IT services of ETH Zurich. We are quite a large section. We are over 40 people, and we do quite a lot of different things like providing services essentially to scientists at ETH Zurich. We maintain the clusters, for example. We provide support for data analysis. We develop software, one of which is OpenBIS, but also other software tools, and we provide services also in the area of data management. So we've heard quite a few times now in this between yesterday and today about fair data management, and nowadays you know better than me that there are the requirements for scientists to publish, first of all, to publish data, and to publish data according to these fair data principles. So data needs to be findable, accessible, interoperable, and reusable. During a research process, a lot of data and metadata information are generated. So in order to avoid drowning in your own data, you really have to keep track of it and manage it from the very beginning of the data generation, and not leave it as a process to do at the end when you come to publication of the data. So this is a situation that we often see. I call it the data spread. So this is what we often see when we work with labs at ETH, but also in other institutions. So there are often in projects, in a research group, there are often different components that are part of the research process. So you have maybe your protocols, your materials, the code, the data that are spread a little bit everywhere in different types of storages that may be available to you. And then still very often paper notebooks are used, and there is no connection between the experimental description and the digital data. So we want to go more towards a solution where you have everything in one place, and this is what we try to achieve with OpenBIS, which is the software we develop. So OpenBIS has been developed at ETH since 2007, so it's been around for quite some time, and it is an open source software. It's distributed under the Apache v2 license. So it has three main components to it. One part is the inventory management. So with this, in this part, basically you can manage your samples, your reagents, your equipment, if you want to, and your protocols if you have them. So the standard operating procedures. Then there is the electronic laboratory notebook part, where you can describe your experiments and also describe your processes and the data analysis. And finally, the data management part. So you can store data of any type and any size linked to your experimental description. So this is how the interface of OpenBIS looks like. We have an inventory part where we can have, for example, collections of materials. And here you see one example of one collection. In this case, they are chemical AD mixtures. Then you can have collections of methods, and if you have them, or if you want to have it, also a collection of equipment, and these can be completely customized. So what you see here can be customized depending on the group. So I took this example from one of the groups we are working with at the moment at EMPA. Then in the electronic laboratory notebook part, each user normally has their own personal folder where they can create projects, experiments, and experimental steps. And here you see an example of one experimental step where you can have a description. And here we have this section that is called the parents. The parents are basically other entities that you have stored in OpenBIS, which you can connect. And then you see also, you can visualize these connections like a graph. And in this case, you see that, for example, this experimental step is connected to a media, a protocol, a couple of buffers, and the yeast. So these are the things that the protocol that I used, that I followed in this particular experiment, and the samples that I used. And these would be stored in the inventory part of the system. And finally, there is the data. So the data is stored in connection to the particular experimental step. So this was the data that was generated in this particular experiment. We have the raw data, in this case, the analysis scripts and the analyzed data. So data can be ingested in OpenBIS in different ways. One way, the easiest I would say, is via web upload. So there is an upload button via which you can upload data, and this is fine if your data are not too large. So when we are in the range of low gigabytes. You can do this also using an API, so the Python API, and this again works well if you have data which is in the low gigabytes. And finally, we have what we call a Dropbox mechanism. And this is suitable for data that is large in size. So here we can upload also hundreds of gigabytes of data. And this process can be manual or can be automatic. So data can be uploaded, basically can be transferred from an instrument to the Dropbox folder. This has nothing to do with the commercial Dropbox software. And then finally, the data in all cases will be uploaded to OpenBIS connected to a given experimental step. So in terms of data analysis, OpenBIS doesn't provide anything for data analysis in the sense that it's a data management platform, an ELN, so it's not a software, it doesn't have any tools itself for data analysis, but what we can provide is a connection with Jupyter notebooks, which are now very popular and very much used in the scientific community for data analysis. So we can provide a Jupyter Hub server that can be connected to OpenBIS. And then what you can do is you can launch Jupyter notebooks from the OpenBIS interface. And for those of you who are not familiar with the Jupyter notebooks, this is how an example of a Jupyter notebook would look like. You can have a mixture of text, your code, and the output of your code in there. And then what you can do is once you have run your analysis on the data that you have stored in OpenBIS, you can store the notebook with the analysis and the results back to OpenBIS. And it will be connected to a specific experimental step or experimental description and to the data that you have analyzed. And we also provide a Jupyter Lab OpenBIS extension. So if you don't want necessarily to use the Jupyter Hub server, but you prefer to work with your own local installation of Jupyter, you can install this extension, which allows you to connect to OpenBIS, essentially then download data and re-upload data back to OpenBIS. So some of the main OpenBIS features, I mentioned before the relationships, so you can establish relationships between entries between entities in the system, in different parts of the system, and this allows you to reconstruct the history of something. So if you have a sample that you have used in different experiments, for example, you can see the history of the sample, or you can connect instruments to measurements, so you can see all the measurements that have been taken with a particular instrument and so on. You can import any kind of data in OpenBIS, and you can also export from OpenBIS in open formats. So you can export tables in tab-separated files, and you can export a complete notebook from OpenBIS with also all the data attached and the metadata will be exported in formats which are HTML, text file, and JSON file. Then we have user rights management, so it is possible to give different users different types of access to the system and access to different parts of the system, so you can control these. OpenBIS provides an audit trail. This means that basically all the changes that you make to entries in OpenBIS are stored in the database, and then you can see them in the user interface, so you can see what was changed by whom and when. OpenBIS has this concept of data immutability, which means that basically the data files that you upload to OpenBIS cannot be modified, so they are read-only essentially. For experimentalists, we offer the possibility to visualize the storage of their samples. So if you have the possibility to customize the fridges and freezers that you have in the lab, and then you can visualize where your samples are located in these storages. We also offer support for working with barcodes. So if you have barcodes assigned to samples, you can scan these barcodes and then recognize your samples toward an OpenBIS connected to this barcode. OpenBIS provides also several APIs, application programming interfaces, so it is possible to interact with OpenBIS in a programmatic way. We have a Java API, JavaScript API, Python API, which I already mentioned before. And finally, another important feature is the connection with data repositories. So if you have data in OpenBIS because you use OpenBIS daily, and so all your data are in OpenBIS, and then you want to publish some of this data in one of these repositories, such as Zenodo, or the research collection is only relevant for ETH Zurich, you have an easy way to transfer the data from OpenBIS to one of these repositories. So as a general consideration, I would say that with OpenBIS and the integration of tools such as Jupyter Hub and the integration with data repositories, we are able to cover most of the data lifecycle. We have at the moment ongoing work to combine the data management solution with some platforms that address the reproducibility of data analysis. So we have, for example, planned work of integrating OpenBIS with AIDA, which has already been mentioned today, and I believe there will be a talk about it tomorrow, and other platforms such as Renko. So I just want to say, before I finish, a few words about the services that we offer for the academic community. So I said before that OpenBIS is an open source software, so anyone is free to download it and use it by themselves. But we also provide services based on OpenBIS. So we provide services to the Swiss academic community, where we can either provide OpenBIS on the cloud using a Swiss cloud infrastructure, or if this is not suitable, we can also provide support for self-hosting OpenBIS. We provide training and support, and these are some of the current customers in Switzerland. And since last year, we also have a European project that is funded by the EGI ACE, so in the framework of Horizon 2020. And thanks to this program, we have also been working with some European academics. And in this case, we don't provide the solution on the cloud, but rather we provide consulting and support for self-hosting OpenBIS. And also in this case, we provide training and support. And these are some of the users that have been working with us in the last year. So it's primarily the German community, I would say, in the European framework. If you are interested, then you can visit our website and you can contact us. So we would be happy to hear from you. This is the team behind OpenBIS. So we have, this is the development team working on developing the software. Then we have the research data management team. So I am part of these. These are the operational guys, so the ones who maintain the servers for the services we provide. And this is our management team. And finally, I have a last slide where you can find some useful information, the documentation and the tutorial, the website of our section, and then you can follow us on Twitter and the help desk. So if you want to have some more information, please reach out to one of these addresses. And I'm happy to take questions if there are any. Thank you.